Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today we're getting into Kotlin. It's a programming language that's really making waves, moving beyond just being trendy to become pretty foundational in software development.
Yeah, definitely seeing that.
So if you're interested in, smoother workflows, maybe dodging some common coding headaches or just getting a handle on where tech is heading, you're in the right spot. We've been looking through an introduction to Kotlin to pull out the key stuff. Our mission, basically.
Yep.
Give you a clear, quick rundown of where Kotlin came from, what makes it tick, its advantages, where it's used, and what's next for it.
Sounds good. Let's do it.
Okay, so origins first. Where did this thing even come from?
Well, what's really interesting, I think, is its roots. It wasn't some academic project. It came from JetBrains.
Ah, the IntelliJ IDEA people.
Exactly. The folks behind that huge Java IDE. They started working on Kotlin back in, 2011? And they had some very specific practical goals right from the start.
Right, and these weren't just theoretical wishes. They came from, real-world developer frustrations, didn't they?
Totally.
Our source highlights things like, well, first, seamless Java interoperability. That was huge.
Crucial.
And making the code itself more concise, more expressive, less typing, easier to read.
Yep. Less boilerplate.
And the big one, for many Java devs, built-in null safety, getting rid of those null pointer exceptions at the language level.
Oh, yeah. That alone was a major selling point. You had this company, JetBrains, deep in the developer world, seeing these persistent issues with Java verbosity and safety, and they decided, okay, let's build something better.
And then came the tipping point.
Right. 2017, Google steps up and basically says, okay, Kotlin is now a first-class language for Android development.
Wow. That must have been massive.
It was a game changer. Huge endorsement. It just turbocharged adoption, especially in the Android space. Makes you think about how one big player backing a technology can really shift the landscape.
Yeah, absolutely. It probably addressed a lot of needs Android developers had for something more modern, more robust than older Java versions, I imagine.
Definitely felt that way. A breath of fresh air for many.
So, okay, for someone maybe hearing the name but not sure exactly what it is, what is Kotlin, fundamentally?
Okay, so at its core, Kotlin is a statically typed language,
Yeah.
meaning the compiler checks your variable types before you run the code. Catches a lot of errors early on. Think of it like a spell check, but for your code's logic, in a way.
Got it, like a safety net.
Exactly. And it's compiled, and it runs on the Java virtual machine, the JVM.
Ah, so that's the Java connection.
That's the key. Running on the JVM means it plays perfectly with all existing Java code and libraries. You can literally have Kotlin files and Java files in the same project calling each other. No problem.
That's incredibly practical. No need to throw out existing Java work.
Precisely. It makes adoption way easier.
And it's flexible too, right? It does object-oriented and functional programming.
Yeah, it supports both paradigms. So you can structure code around objects like in traditional Java, or you can use functional approaches, treating functions as first-class citizens. Gives developers options depending on the problem they're solving.
Flexibility is always good.
Definitely. And then there's that null safety thing we mentioned. We should probably dig into that a bit more.
Please. How does it actually work?
Well, basically, in Kotlin, the type system itself distinguishes between references that can hold null and references that cannot. By default, things can't be null.
Okay.
If you want something to potentially be null, you have to explicitly mark it as such, usually with a question mark after the type.
Ah, so you're forced to think about it up front.
Exactly. The
Yeah.
compiler forces you to handle the possibility of null wherever it might occur. So you don't get those unexpected null pointer exceptions crashing your app at runtime nearly as often. It's designed out.
Man, anyone who's chased those bugs knows how valuable that is. Sounds amazing. But it's got more modern tricks up its sleeve too, doesn't it?
Oh, yeah. Several cool features, like extension functions.
Extension functions.
Yeah, they let you add new functions to existing classes without actually modifying their source code or inheriting from them.
How does that work?
Think of it like adding a new button to an app you downloaded without having the app's original code. You just extend its functionality from the outside. It's super useful for adding utility methods to standard library classes or third-party code.
Interesting. Keeps things clean. What else?
Data classes. These are brilliant for classes that primarily just hold data.
Like a user class with name, email, etc.
Exactly. In Java, you'd write constructors, getters, setters, equals, hash code, toString, lots of boilerplate.
Right, pages of it sometimes.
With Kotlin, you just declare a data class, list the properties, and the compiler generates all that standard stuff for you automatically.
Okay, that sounds like a huge time saver. Less repetitive code.
Massive time saver. Then you've got coroutines.
Ah, yes, coroutines. Heard that term a lot. Async stuff, right?
Right. They're Kotlin's way of handling asynchronous programming, like making network requests or database calls without freezing up your application.
Which traditionally involves callbacks or complex reactive frameworks.
Yeah, callback hell is a common term. Coroutines let you write asynchronous code that looks almost like regular sequential code. It's much easier to read, write, and reason about. It's like pausing and resuming code execution very efficiently.
So simpler async code. Nice. Anything else major?
One more worth mentioning is type inference.
Okay.
Often the Kotlin compiler is smart enough to figure out the type of a variable from the context, so you don't always have to explicitly declare it. Like if you write val name Kotlin, the compiler knows name is a string.
Less clutter in the code.
Exactly. Reduces verbosity, makes things a bit cleaner. All these features together really aim for developer productivity and code safety.
Okay, it sounds like a compelling set of features. Let's crystallize the why, though. If someone's considering it, what are the absolute key advantages? Why choose Kotlin?
All right, let's list them out. Number one, definitely the concise and readable code. Less boilerplate means less code to write, less to read, and fewer places for bugs to hide. Faster development.
Makes sense. Quicker to understand, too, if you're jumping into a project.
Absolutely. Two, null safety. We've talked about it, but it's huge. Prevents a massive category of runtime errors. More robust applications.
I totally state that one.
Three, interoperability with Java. Being able to use existing Java libraries, frameworks, and even mix code in the same project is a massive adoption advantage. You leverage decades of JVM ecosystem development.
So it's not an all-or-nothing switch.
Not at all. Four, coroutines for asynchronous programming. A much simpler, more structured way to handle complex async tasks compared to older methods.
Essential for modern apps that talk to the network constantly.
Yep. Five, multi-platform support. This is increasingly important. Kotlin Multiplatform, KMP, lets you share code, especially business logic, across different platforms. Think Android, iOS, web, backend.
Write once, run, or at least reuse logic everywhere.
That's the goal. Huge potential for efficiency gains there. And finally, six, strong tooling and community. Being backed by JetBrains, the IDE experts, and Google means fantastic IDE support, great tools, and a rapidly growing enthusiastic community.
That backing provides a lot of confidence in its future, I bet.
It really does. You know, it's well supported and actively developed.
Okay, those are strong points. So where is Kotlin actually being used right now? What are the main application areas?
Well, the biggest one, no surprise, is Android app development. Since Google's endorsement, it's become the preferred language. Most new Android development happens in Kotlin.
Makes sense. What about beyond mobile apps?
It's making really solid inroads into back-end development. Frameworks like Ktor, which is built by JetBrains, or using it with Spring Boot, for example. It offers a modern alternative to Java for building server-side applications.
Interesting. So competing with Java on its home turf there.
To some extent, yeah. And connecting back to mobile, that cross-platform mobile development with Kotlin Multiplatform is a growing area. Sharing code between Android and iOS apps is a big draw.
Trying to solve that write it twice problem.
Exactly. And we're also seeing it in web development with Kotlin.js. You can compile Kotlin code to JavaScript to run in the browser for front-end work.
So full-stack Kotlin is possible.
It is. And even in areas like data science and scripting, while maybe less mature than Python in that space, the ecosystem is definitely growing. People are starting to use it there, too.
Wow, it's really quite versatile then. Android, backend, web, cross-platform.
Yeah, it's spreading its wings.
Okay, but let's bring some balance. No technology is perfect. What are the downsides or challenges people should be aware of with Kotlin?
That's fair. There are trade-offs. One that comes up is compilation speed. Sometimes Kotlin compile times can be a bit slower than plain Java.
Ah, okay. Is that getting better?
It is. JetBrains is constantly working on optimizations. Things like incremental compilation have improved a lot, but it's still something people sometimes notice, especially on larger projects.
Good to know. What else?
The talent pool. While it's growing incredibly fast, the number of experienced Kotlin developers is still smaller than the vast number of Java developers out there.
Right. Especially in big enterprise shops, maybe.
Yeah. Finding senior Kotlin devs might be harder or more expensive than finding Java devs in some markets, though that's changing rapidly.
Makes sense. It takes time to build that critical mass.
Another point is, while the Java interoperability is generally excellent, it's not always 100% seamless. There can be occasional small quirks or edge cases when mixing the two languages, especially around things like nullability annotations or generics.
So mostly smooth, but you might hit the odd bump.
Pretty much. Usually requires just a bit more understanding of how both languages work under the hood in those specific cases.
Okay. And for Java developers switching over, is there a steep learning curve?
It's generally considered one of the easier transitions, especially compared to switching to a completely different paradigm. Kotlin feels familiar in many ways,
What?
but there are new concepts to grasp properly. Coroutines, extension functions, the nuances of null safety, some functional idioms. It takes time to become truly idiomatic Kotlin developer, not just writing Java-style code in Kotlin files.
So gentle curve, but still a curve that needs climbing to get the full benefit.
Exactly. You need to invest time to learn the Kotlin way of doing things.
All right, those seem like reasonable considerations, not showstoppers. Looking ahead then, what's the general feeling about Kotlin's future?
I'd say the outlook is overwhelmingly positive. The momentum is really strong. You have continuous development from JetBrains, strong backing from Google, especially for Android,
And that growing community we mentioned.
and the community. It all points towards continued growth and evolution. It's not standing still.
And that multi-platform aspect feels like a big part of its future potential, right?
I think so. Kotlin multi-platform could be huge. The idea of unifying development across so many different targets, mobile, web, desktop server with shared logic, is incredibly appealing in today's fragmented tech landscape. It positions Kotlin really well for the future.
Yeah, that sounds potentially game-changing if it fully delivers on that promise.
Ah.
So bringing it down to the individual listener, who should really be thinking about learning Kotlin? Who benefits most?
Well, pretty clearly, Android developers. If you're doing Android work, Kotlin is pretty much the standard now. It offers significant advantages over older Java versions for that platform.
A must-learn there, basically.
Pretty much. Then Java developers. If you're already comfortable on the JVM but want more modern features, less boilerplate, better safety, without leaving the ecosystem entirely, Kotlin is an excellent next step.
Enhancing productivity within a familiar world.
Exactly. Also, developers interested in cross-platform mobile development or even backend development where they want a modern JVM language, Kotlin multi-platform makes it super relevant there.
So anyone looking to build from multiple targets efficiently.
Yeah, and honestly, just anyone who appreciates writing concise, expressive, and safer code, if those qualities appeal to you in a programming language, Kotlin is definitely worth investigating, regardless of your current background.
Okay, that makes a lot of sense. So wrapping this up, the big takeaway seems to be that Kotlin effectively marries the rock-solid foundation and ecosystem of Java, the JVM, with a whole suite of modern language features designed for, well, better, safer, faster development.
That's a great way to put it. It addresses many of Java's historical pain points while retaining its strength.
And it seems really well suited for the demands of today's fast-paced software world, especially with that potential future in cross-platform development.
Absolutely. It's a language built for modern challenges.
So maybe a final thought for you listening. As these modern languages like Kotlin continue to evolve how we build software, how might learning or adopting them change your path in technology? What doors could it open? Something to think about.
Definitely something to consider. The landscape is always shifting.
Indeed. Well, thanks for digging into Kotlin with us today.
My pleasure.
Until the next deep dive. Keep exploring.